Hey guys, welcome back to our channel. So this channel, Everyday Data Science, is all about trying to learn the different concepts involved in data science by practicing a lot of questions. In this video, I'm going to solve this question and start at scratch regarding risky projects both using Python as well as MySQL and try to walk you through how we can develop solutions to such problems. The difficulty level of this question is medium. This question has been asked in LinkedIn interviews and it's a great question if you are preparing for data engineer, data scientist, BI analyst, data analyst or ML engineer roles. Okay, let's jump right in. The question reads, identify projects that are at risk for going over budget. A project is considered to be over budget if the cost of all employees assigned to the project is greater than the budget of the project. You will need to prorate the cost of employees to the duration of the project. For example, if the budget for a project that takes half a year to complete is $10,000, then the total half year salary of all employees assigned to the project should not exceed $10,000. Salary is defined on a yearly basis, so be careful how to calculate salaries for the projects that are less or more than 1 year. Output a list of projects that are over budget with their project name, project budget, and prorated total employee expense rounded to next dollar amount. So don't get confused by this. It is not rounding, it is basically ceiling. So even if it is $10.2, so you need to round it to the next dollar. So after 10.2, it should be $11, right? So something like that. To make it simpler, consider that all years have 365 days. You don't need to think about the leap years. Okay, so basically we are given three different data frames: LinkedIn project, LinkedIn employee projects, and LinkedIn employees, and our expected output is a pandas data frame with three different columns: title, budget, and the prorated expense, and only those rows where your prorated expense is greater than that of the budget of that project, right? So let's see how the information is stored in these three different tables or data frames. So LinkedIn projects has 5 different columns: ID, title, budget, start date, end date. So and then the next one, employee projects, also has 2 columns: employee ID and project ID. And the third one, LinkedIn employees, has ID, first name, last name, and salary. Okay, so since all this information is scattered in 3 different data frames, so obviously the first thing is should be to merge everything at one place so that we can perform the next calculations. Now if you look at it, right, so this is the table. This middle one, LinkedIn employee projects, is the table that is going to create that link, because using the employee ID in this table and ID in this, you can merge these two, and using the project ID in this, you can merge it with LinkedIn projects. Okay, so what we can do is we can start with it, right? So let me just LinkedIn employee projects, and then let me start with merge this, right? So let's merge this with the employee ID. So I can either go up or down, but since we already have the employee ID, in this case let me go down and try to get the salary first, right? Because that is going to be used, right, to calculate whether the budget is going to be more or less than the total prorated expense. So let me merge LinkedIn employees data frame, and since the name of the columns in these two different data frames are different, so we need to use left on, right? So left table is this, right, LinkedIn employee projects, and here your name of the column is employee ID, right? So employee ID, and right on, so right table is LinkedIn employees, and here the name of the column is ID, right? ID. And how do we want to merge? How is equal to left, right? So why we are merging left? Because this is the table, employee ID and project ID. So obviously all the employees and whatever projects they are assigned to. So we are only concerned about employees that are in this table, right, and what their salary are, right? Okay, so once we have this, let me go ahead and run this. Let's see what we get. Okay, so if you look at it, so employee ID and project ID comes from LinkedIn employee projects, and then all the different columns come from LinkedIn employees. So you have various employee IDs, project IDs, right? And these are the project IDs and the salary that you have. Okay, now once you have this, then you need to merge this information, right? So remember, you have all this information, all these 6 columns, and then you need to go back and merge this with the LinkedIn projects. Why? Because there are two things that you will get from here. Firstly, or two or three things, right? So you will get the title and you need the title in your output, right? Secondly, you will get the budget of the project, right? So you can get the budget. And thirdly, you can use these two columns to calculate what is the prorated expense, because start date, end date, so number of days between them, that multiplied by salary divided by 365. Why? Because salary is for a year, so you divide by 365, so that is the number of salary for a day, right? Or amount of salary for a day. And when you multiply the amount of salary for a day to the total days the project should last, it is going to give you the prorated cost of that employee, right? So let me go ahead and merge this. So merge, and then now we are merging with LinkedIn projects, right? So LinkedIn projects, right? LinkedIn projects. And now again, name of the columns are different. So left in this is the merge table that you got right now. So left in this, so we are merging the project, right? So left on project ID, and right on, this is the table, so right on ID, right on ID. So once you merge this, and then how do you want to merge? Again, left, because whatever you got from the initial merge, right, you only are concerned about what are the titles, budget, and start and end dates of them, right? So is equal to left. Okay, now let me go ahead and run this. Let's see what we have. Okay, so employee ID, project ID, and since the name of the columns after merge, you have two columns with same name, IDs. This is the employee ID, right? Employee ID coming from LinkedIn employees. You can see employee ID and employee ID, right? And this is the project ID, right? But obviously you don't need everything that is here, right? You don't need first name, last name. You like, why do you need so many IDs and all that, right? So let's only keep certain values, right? Whatever we need. So first thing that we need is, we obviously need the project ID, right? So we need the project ID. We need the salary part for definitely, right? So we need the salary part. We need the title because that is required in the output. We need the budget because that is going to be used to compare, right? And we also need the start and end dates, right? Because that is going to help us calculate the prorated cost, right? So start date and end date. Okay, I don't think we need anything else. Employee ID. Okay, cool. Let me run this. Let's see what we have. Okay, so project ID, salaries, title, budget, start date, end date. Okay, so now once we have this, let me save this in a data frame. Now what we can do is, we can go ahead and make a column which is going to basically calculate the prorated cost, right? So let me make a column, let's say prorated cost, right? So cost of each employee. So for example, this was a particular employee, right? So I didn't keep employee ID. Let me just keep again, right? So it would be easier to explain. So employee ID, and this should be a comma. Let me remove this for now. Run this again. Okay, so this employee was assigned to a project called project ID 1, whose salary was this much for a year, and the project's title is this, budget is this, start date and end dates are these, right? So now I can calculate, okay, for this particular employee, what is going to be the prorated cost, right? So that is what I was trying to do. So prorated cost, right, is equal to, now first thing we need to do is, we need to calculate the total number of days between start date and end date. To do that, what we need to do is, we need to import a library called datetime. So import datetime as dt, right? So what do you need to do is, firstly df dot end date minus df dot start date, right? So from this column calculate the difference, and then get the days, right? So you get the days, and then how do you get the total cost? You multiply by the salary. Salary is df dot salary, but this is the annual salary, right? So you got the total number of days. Now you need to multiply it by the daily salary, right? So you have the total salary, and the question says that only assume that every year has 365 days, so you divide it by 365. Okay, so now let me go ahead and run this. Let's see what we have now. So you have all these and prorated cost, right? So let's not care about rounding off yet, but okay, so you have for each of these employees the total prorated cost. Okay, nice. Then what we can do is we can go ahead and group by the title and try to see, okay, what are the for different projects, right? What are for the different projects, what is the total prorated cost, right? So whatever number of employees I have been assigned, sum the total prorated cost. So we can write df dot group by the title, right? Group by the title and then take the prorated cost column and calculate the sum, right? And since we group by title, we need to reset index so that it appears in the column. If I run this, so you have for various titles what is the total prorated cost, right? Now let me save this in another data frame. Let's write df2 and let's go ahead and now perform that ceiling function, right? Why? Because we are not rounding, we are ceiling, because it says rounded to next dollar amount, right? So to do that, we need to use the ceiling function in NumPy library. So we need to import NumPy as NP, right? NumPy as NP, and then let me go ahead and write, okay, so df2 prorated cost is equal to df2 prorated cost dot apply, right? So dot apply and np dot seal, and let me just run this. Let's see whether it was rounded to next dollar. Okay, so this is rounded to next dollar. So now we have different titles and the prorated cost, right? The total prorated cost. And now what do we need to return? We need to return the title, the budget, as well as the prorated expense. So prorated expense, this is what we have. We can just rename it. We need to get the budget as well. Budget is in this data frame, right? So you see budget column is this. So what we can do is we can go ahead and merge this. So df2 dot merge this, right? Merge this with the df data frame that we created by merging all the three given data frames, right? And then how do you merge? So if you see title is here as well, right? So we can simply go ahead and write on title, right? And then how is left, right? And okay, let me go ahead and run this. Let's see what we get. Okay, so you have title, you have prorated cost x, prorated cost x. Why this is x and y here? Because here if you see df, right? So and once you have the df, you made a new column prorated cost, right? And df2 also has prorated cost, right? Because df2 we applied the ceiling function, so that is why x is so prorated cost x is coming from df2 and prorated cost y is coming from df, right? And this is not the rounded one, this is the rounded one, right? So we are only required to keep this one, right? So once you have this, then what we can do is we can keep only certain columns, right? So we can keep the title because that is required in our output. We can keep the prorated cost x because that is the ceiling one, right? And we need to take the budget as well, right? Take the budget. Okay, let me run this. Now if you see there are duplicates here, right? So we can go ahead and drop duplicates. So drop duplicates, right? Again run this. Okay, so this is cool. Now let me go ahead and since this is budget first and prorated expense again, right? So let me just cut this out here and paste it here so that we have the correct order, right? Let me run this again. Okay, so title, project, and budget and prorated cost. And let me go ahead and rename this as well here, right? So rename, we need to rename columns and it should be changed from prorated cost x to prorated expense, right? So prorated expense. Okay, let me go ahead and run this. Okay, so now you have title, budget, prorated expense. So this is not complete yet. Why? Because we need to make sure that only those rows are output where prorated expense is greater than the budget, right? That is what the question says. So what we can do is we can save this in a data frame called df3 and then use Boolean indexing. So df3 column prorated expense is greater than df3 budget, right? So this makes sense. Let me run this. So now you have various projects, right? 29498, 36293, right? So if you look at it, our output looks exactly like expected output. Let me go ahead and submit it to see if it passes all the test cases. So yeah, everything is green, and this is how we do it. Yeah, lengthy, but like this is how we do it. Now let's see how the corresponding code looks like in MySQL. Okay, so if you look at it, same question, 3 different tables, expected output is same as well, right? And if we preview the tables, they have information stored in a similar way, right? Information stored in a similar way. Okay, so what we can do is we can start with the same thing, that start from this table, LinkedIn employee projects, right? LinkedIn employee project, let's alias this as a left join the the employee and their salaries table. So LinkedIn employees aliased as b on a dot employee id is equal to b dot id, and then let's left join the third table that we have, which is LinkedIn projects, right? So LinkedIn projects aliased as c on a dot project id, right? So here if you see project id, right? So a dot project id is equal to c dot id. Okay, c dot id. Okay, so once you merge this, then again, like you don't need to keep everything, right? So what we can do is we can from this LinkedIn employee projects, right? LinkedIn employee projects, we can keep the employee id. Project id is already in this table, right? Project id is in LinkedIn projects table, right? So what we can do is we can keep a dot, right? So a dot employee id, then we can keep the employee from this table. We can only, so we have already the id, we only need the salary in this case, so we can do b dot salary, and then from C we can keep everything. Why? Because most of the things are relevant in this case. So you have ID, title, budget, start date, end date, so you need all that, right? Let me go ahead and run this. Let's see what we have. Okay, so employee ID, salary, this is the project ID, title, budget, start date, end date. Okay, so now once you have this, then what you can do is let's save this in a common table expression, right? So with CTE as, and then this entire thing goes into parentheses, right? And now from this common table expression, what we need to do is we need to group by the title, right? So let me group by the title, right? So group by title, right? And obviously return the title, and then how do you get the obviously the prorated cost? You subtract these and then multiply it by salary divided by 365, right? So date diff, right? Date diff, end date and start date, right? End date and start date, and you multiply it by the salary, right? Multiplied by salary divided by 365, right? Multiplied by salary divided by 365, and once you sum this up, right? So once you sum this up, that is going to give you for each title what is the prorated cost, right? Let me write as prorated cost, or like what is required in the output, prorated employee expense, right? So prorated employee expense. Okay, let me run this, right? This is not yet complete, but let me run this. Let's see what we have. Okay, so various projects and their prorated employee expenses, right? Obviously you need to round this again. Now what we need to do is, so here if I just use the ceiling function, right? Ceil function here, and if I run this again, so this will be rounded to next dollar value. Okay, but we need the budget as well, right? Now just, there is one clever thing that you do, or either you can, save this is another common table expression and go by the thing that we did in Python, that, you again merge this, get the budget and all that. But just think about it. You grouped by the title, right? So in this common table expression, you have the salary, you have the budget, right? And all that, right? And all the employees. So if you grouped by the title, you multiply the difference in dates, right? So to get the number of days, and salary divided by 365 to get the prorated expense. But if you just go ahead and sum the budget, so if let's say me and you both have been assigned to project 1. So if I group by the title project 1 and sum the budget, so it is going to be 20, right? Let's say the budget was 10 for project 1, so 10 plus 10, 20. However, if you divide the sum by the total number of people in that group, so 20 divided by 2, so actually you can get the original budget of the project. So what I'm saying is, what we can do is, to get the budget, you can simply do, since you are grouping by the title, so sum the budget, right? Sum the budget, but divide by count star, right? Divide by count star, and it will give you, so the total sum of all the budgets for that particular title, and it is going to be the same because one project has one budget, right? So let's say 2 people are assigned to project 1, so you sum this plus this and divided by 2, so obviously you get this back, right? Let me run this, right? Or let me just alias this as budget. Let me run this, let's see what we get. So you see, project 1, you get back the budgets as it is. Now again, you need to keep certain things only, right? Where your prorated employee expense is greater than the budget. So since you group by, then again what you can do is, you can save this in a common table expression, and then from that second common table expression, keep only those rows where prorated employee expense is greater than budget. But since you have grouped by, remember, by the aggregate value, you can directly filter out things. How? You can use the having function. So you can write having, right? Having, and then what do you need to do? Basically, this entire thing, right? This entire thing, having this entire thing should be greater than the budget, right? So this entire thing, right? So just copy and paste it here. Now let me run this. So you have title, budget, and prorated employee expense of only those projects where your prorated employee expense is greater than the budget, right? So I think this looks good. Let me go ahead and submit it to see if it passes all the test cases. So yeah, everything is green, and this is how you do it. So not a very difficult question, but yes, definitely very lengthy question, because you have 3 different tables or data frames to deal with and a lot of columns. But if you just use these tips and tricks here and there, you can do this, right? Let me know if there is a better way or a more efficient way you can think of to solve this question. Let the solution be in the comment section below, and I will see you guys in the next video.